usually downhill in a thermodynamic sense. They're exergonic, they're energy yielding, and typically the cell will take advantage of that downhill stuff. If there's a strong downhill reaction, as it breaks down some kind of nutrient, it's going to try and save as much of the energy of that downhill ride as possible in the form of ATP, harvesting some of that energy. And it's usually oxidative in nature. Fuel molecules donate their electrons two at a time, and they don't go to oxygen immediately like it would in a fire situation, where the electrons go straight from the substrate to oxygen. In cell oxidation, it's handed off initially to carriers. NAD is one of the main types, NADP, there's even a third kind. And then these guys ultimately, in turn, hand off electrons to oxygen. So our foodstuffs are reduced forms of carbon. We've seen this slide before. Here's various oxidation states of carbon. Our foodstuffs are typically in this range, fully reduced, partially reduced. And during catabolic reactions, we're headed towards total oxidation of carbon to CO2. So we're giving up electrons, replacing hydrogens with oxygens. And so the point is, as you move in this direction, stripping off hydrogens, replacing them with oxygens, some of those hydrogens show up and being carried by these molecules NAD and ADP. These are so-called redox carriers. They're electron carriers. And of course, the more reduced, the more electrons, and hence potential to make more energy. So fats are higher energy than carbohydrates. There's CH2O formula. Carboxylic acids like acetic acid, vinegar, and stuff like that are way down here, mostly oxidized.
Sorry, you said the more reduced, the more oxidized?